All right, so on to page 2. We have an example here of problem number 10 says Ping and Celicia each attempted to factor this polynomial by factoring out the greatest common factor. And so we've got Ping's work over here and Celicia's work over here. Analyze each student's work, determine which student is correct, and explain the inaccuracy in the other student's work. So let's zoom in a little bit. Okay, so Ping here said that these three terms could all be divided by 3x. So let's see, x squared, 4x, and yep, that would be negative 12. Celicia said that each of the three terms could be divided by 3, which that is accurate. However, because we're supposed to be factoring out the greatest common factor, Celicia left behind, if you look at these three terms right here, there's an x in all three of them, which means that there is a GCF here, or a common factor of an x, that she did not take out. So determine which student is correct. All right, let's start there. Ping is correct. Okay. Explain the inaccuracy in the other student's work. Celicia did not factor out the common x from each term. So it's not that the 3 was incorrect, it's just that 3 isn't enough to be considered the greatest common factor. All right. Now, part B says to completely factor the expression that Ping and Celicia started to factor. So I'm going to go ahead and grab what Ping did. So 3x and then x squared plus 4x minus 12. And basically I want to look at factoring this middle section right here, this trinomial. So I'm looking for, let me zoom in here, what can multiply to negative 12. Let's try that again. There we go, multiply. And what's going to add up to positive 4. So the 3x won't change. Let's see. If I go with 6 and 2, let's make a positive 6 and a negative 2. So let's see. 6 times negative 2 is negative 12. 6 minus 2 is 4. So this is the completely factored form. Okay. Now we want to use the factors to identify the zeros. So remember, each one of these factors is going to be set equal to 0. So 3x equals 0, x plus 6 is equal to 0, and x minus 2 is equal to 0. I'm going to zoom in on just that section. So let's see, x is equal to 0, x is equal to negative 6, and x is equal to positive 2. Okay, so we've identified our zeros, and then sketched the graph of the polynomial. Now, this does not have to be perfection. What I would like you to do, though, is label that 0. Let's go ahead and call that 2. Let's call this negative 6. Okay, now this is a cubic function with a positive a value, which means we are going to start low, curve through our x-intercepts, and then end high. So that's kind of what the graph might look like. Again, it's a sketch, right? If I wanted perfection, I'd actually ask you to grab Desmos or Calculate84 and graph it. This is just to give us a sketch to figure out kind of what the general focus of this graph looks like, okay? Now, we're going to do the same thing for problem. I'm going to do 11 and 12, and then 13 and 14 I'll just leave in the answer key. If you have any questions, let me know. So we want to factor the polynomial, identify the zeros, and then sketch the function, okay? So if I look at problem number 11 here, we've got f of x is equal to, the first thing I'm going to look and see is that each one of these has a common factor of 3x. Okay, so I'm going to give myself a little bit more room to work. I always do that. Okay, there we go. So GCF is 3x. Let's see what's left over. So that would be x squared plus an x minus 2. Now I want to see, whoops, sorry about that. I want to see if I can factor this trinomial more. All right. So remembering that you're going to try to multiply to -2 and add up to, there is a little solitary 1 in here. Remember that we can add. So multiply to -2, add to 1. So how about x plus 2x minus 1? Let's check it. All right, 2 times -1 is -2. 2 minus 1 is 1. All right, I now know I have the right factors. Okay, so we have factored the polynomial. Now I want to identify my zeros. So I'm going to take each of my factors, set it equal to 0, and solve. So x is equal to 0, x is equal to -2, x is equal to 1. All right. Now I'm going to use those zeros and I'm going to mark them on the graph. So here's 0. Let's call this -2, and let's call that +1. Okay. So cubic function, positive a value. We're going to start low and then cross through your x-intercepts and then end high. Okay. And yeah, I did leave a little gap here because I didn't want to draw straight through the -2 and make you guys think it was a +2. So obviously you can move the numbers over. You could draw the sketch in first and then label everything. Whatever works. All right, last problem for this video. And then like I said, I'll put 13 and 14 in the answer key and you guys can ask me any questions that you have. For problem number 12, we've got, let's see, f of x is equal to, first things first, I never give myself enough space. Slide that on down. Okay. I'm going to take out the GCF of 2x. Okay, everything can be divided by 2 and both terms share an x. So take that 2x out. So we're left with x plus 3. There's nothing left to do here with x plus 3. We can't factor this anymore, so this is the factored form. I am going to take each factor equal to 0, and I am going to solve for my zeros. So x is equal to 0, x is equal to -3. So you've got 0 here. I'll call that 0. We've got -3 here. Okay. Now, this is a quadratic function with a positive a value. So this is that U-shaped parabola graph. So make it, parabolic. All right. So it looks something like that. Again, I'm not looking for perfection on these. It's just to get the feel for what the graph looks like. And then also understanding how those zeros and factors are related to each other. All right, so this is going to be the end of this video. For anything that we didn't cover, 13 and 14, I'll go ahead and pop those up in the answer key. And if you have any questions or concerns, pop into Zoom and let me know what